Guys, so this is going to be our first video on our extra credit project. The purpose of the first video here is to show you how to do the hand calculations that you need to do to figure out all the different reactions and internal forces for each of the three beams. So basically what we're going to do is we're going to walk through beam number 1 together, and I want you guys to follow along with me. As I do the hand calcs, you do the hand calcs as well, and then in the next video we will focus on entering these formulas that we come up with into our Excel file that the template that I've given you. All right. So for each beam, the process is going to basically be the same. You're going to have a beam. You're going to figure out your reactions in terms of the parameters that have been given to you. All right. And then you're going to use those reactions then to help find the internal forces at each location, also in terms of the parameters. All right. So let's just start with beam 1. All right. This is beam 1. Okay. Let's make that a little thinner. Okay. All right, so for beam 1, I need to find my reactions in terms of P, A, and B. Okay. So on the left, I've got a pin support. On the right, I've got a roller support. There's not going to be any reaction in the X direction, right? So I'm going to have a reaction on the left and a reaction on the right. So this will be reaction left. This will be reaction right. Okay. So I need to first find reactions. And we're going to do that by summing moments about the left supports. All right, so some moments about the left support. What we get is a negative P times A plus the right reaction times L. That equals 0. And then when we solve for the right reaction, we get PA over L. Okay. So that's the right reaction. If we come down, we'll do some forces in the Y so that we can get the left reaction. And what we get is reaction left minus P plus the reaction at the right, which is PA over L, and set that equal to 0. And what we find then is that reaction left is equal to P minus PA over L, which is equal to P minus 1, or I'm sorry, P times 1 minus A over L. If you combine that together, we get P times L minus A over L, and L minus A just equals B, right? So reaction left then is equal to PB over L. Okay, so those are my reactions in terms of my parameters, P, A, and B, and then L just equals A plus B. So now that we have our reactions, I want to determine what my internal forces are, right? So I'm going to come up with an equation for the shear and an equation for the moment. Now, for this particular beam, I'm going to need to come up with an equation for the shear and the moment when X is less than A, and then a different equation for the shear and the moment when X is greater than A, okay? So let's draw these free body diagrams. So let's draw a free body diagram when X is less than or equal to A, okay? What we've got is our support here. We'll make our cut. We have the left reaction, which was PB over L. And then we're going to have our shear and moment that gets exposed at our cut. And remember to draw your shear and moment in the positive sense. If we were to sum forces in the y direction, what we get then is that V equals PB over L. All right. And if we sum moments about the cut, what we get is that our moment comes out to be PB over L times X. Okay. So that is the shear and moment equations for when X is less than A. All right. So let's take a look then at our last step, is free body diagram for when X is greater than A. Okay. Our free body diagram is going to look like something like this. We're going to make our cut. We get PB over L as our left reaction, and then we have P acting, our load P, that's a terrible P, our P that acts at a distance A from the left end, and then we're going to make our cut at a distance X, right? Again, draw your positive shear and moments, and some forces in the Y and some moments about the cut. If we sum forces in the Y, what we find out is that our shear V is equal to PB over L minus P. All right. And if we take our moments about the cut, what we end up with is PB over L times X minus P times X minus A. So that ends up being my shear and my moment equations when X is greater than A, right? So when our X location is on the right side of the applied load P. All right, so now that we have these equations set up, we've got equations set up for the reactions, for the left reaction and the right reaction, and we've got equations set up for shear and moment for both conditions. All right, so that's all we need to do hand calc wise, is to come up with these shear and moment equations. This first problem is probably going to be the hardest one in terms of having to come up with two different equations for when X is less than A and X is greater than A. On beams 2 and 3, you will not need to do this. You will just need to be able to cut one free body diagram and then just have to come up with one equation for the shear and one equation for the moment. So this one's probably the harder one. This is why I chose to help you guys step through this one, and we'll get started with your project this way. All right, so now that we've got all of our equations set up, we've figured out what they need to be. Now it's time to enter these equations into the spreadsheet, and that's what our second video, our part 2, will be over.